Good afternoon and welcome back everyone. Hope this slide is visible and my voice is reaching to you people. Okay, I don't want to consume much time because from the morning we are continuously having sessions. And this fifth unit is a short, it's not lengthy. It's very short and it will fetch you good marks. So please concentrate on here. Our fifth unit is with regard to some advancements that are there in the PLS. Out of those advancements, some of the topics we have already had a look onto it in the fourth unit. So let us try to see what we are going to learn here. We are going to learn what are the attributes of cursor and how do we manage the cursor using those attributes. So we will try to understand what is a cursor and how do we work around with it. Then we will try to understand what are database triggers. We use these triggers, which are background running programs, which will help us to know when a particular event has occurred, and if the event has occurred, what action is to be performed, we can perform using it. Then we will try to understand what is a stored subprogram with examples. The stored subprograms we have already covered in the fourth unit with the help of our functions and procedures. Whenever we create a named function and a named procedure, that particular named function and procedure is called a stored subprogram. So next we will try to understand what is a package, how do we group certain procedures, how do we include those procedures inside a package with the help of two things of the package, two parts of the package. First part is called as specifications, second is called as the body. Then we'll try to see what is overloading and calling of package, how do we use it. So let us start. We have only 6 topics to be discussed in the fifth unit. It's a shorter one. So let us start with the cursor. Cursor, as I said, is a pointer to a list of rows selected by using a select statement. Whatever rows are being retrieved from the table database, those rows will be saved inside a memory location, temporary memory location, and those rows will be referred one after the other with the help of a pointer, and the name of the pointer is cursor. Okay, so let us imagine that there is a huge table of students records which is composed of, let us imagine, 15 columns, and out of the 15 columns we are interested only in the 5 columns, pin number, name and total. Let us say 3 columns only. So what Oracle will do is, once we apply select name, pin and total from student table, Oracle will create a temporary memory trying to hold these 3 column values inside the temporary memory. That temporary memory is called as result set. What is a temporary memory called as? Result set. And to refer to each and every row in that particular temporary memory, Oracle uses an inbuilt pointer called as cursor. Inbuilt pointer called as cursor. If we want to use this cursor, then we have to perform certain tasks. Those tasks are, first of all, we have to set a cursor to that memory location. To set the cursor to that memory location, we have to create or define a cursor using the select command. First thing, we have to create or define the cursor using the select command. Whatever I have said, select name, comma, pin, comma, total from student, that select statement should be written while creating a cursor. Once the cursor is created, we can open the cursor and we can try to use that cursor values pointed by that cursor one after the other using a fetch statement. Using what statement? Fetch statement. Once all the values of the table are fetched out, let us suppose 10 student values were there. All the 10 values have been fetched one after the other. Then this fetch will be pointing from first row to second, second to third, third to fourth, so on till the 10th. Once the 10th row is over, the fetch will not be able to successfully fetch any more rows because there are no more rows. And then finally, we will close the particular cursor so that the memory that was occupied here, temporary memory, can be relieved of or deallocated. So this is the entire procedure of our cursors. Let us try to understand in clarity what is the cursor. The memory area that we discussed here is called as context area. Is called as what? Context area. Cursor is nothing but a pointer to the context area. Cursor in simple terms is the pointer to the context area. Oracle creates a memory area known as context area for processing an SQL statement, which contains all information needed for processing the statement. For example, number of rows processed for that particular selected group of columns. So PLSQL controls that context area with the help of a cursor pointer. This cursor pointer will do is holds the rows one or more written by the SQL statement. The set of rows cursor holds is referred to as active set. The set of rows, the 10 rows which the earlier example was being mentioned with, those 10 rows are called as active sets. Are called as what? Active set. Now, to this active set, cursor will try to create a pointer using which we can fetch the first row. Once we apply a fetch command to the first row, the cursor pointer will point to the second row. Once we apply a fetch command to the second row, the pointer will point to the third row. Once we apply the fetch to the third row, the cursor pointer will point to the fourth row. So on till the last row is fetched. Okay. So one after the other we will read row by row. So this is the entire scenario of your Oracle's cursor concept, PLSQL cursor concept. So in basic terms, what is a cursor? It's a pointer to a context area. What is a context area? It's a memory area created by the Oracle for processing an SQL statement. Okay, so whatever rows are retrieved by the SQL statement which are being processed are called as active set rows. The cursor is a pointer. It points to the first row in the active set, and using the fetch command, one row after the other row, the data will be fetched unless and until all the rows of the fetched active set are finished. Okay. So there are certain attributes using which we can control the cursor. One of the attribute of the cursor is percentile found. This percentile found returns true if any of the insert, update or delete statements affected one or more rows or a select into statement. What do I mean is here, percentage found will return true if any row is affected by using the insert, update, delete or select statement. If no row was affected by the insert, update or delete statement, and if the rows were not found, then it returns false. Suppose you applied an insert command, suppose update command for a particular row in which pin number was 39, and in the actual table 39 pin number was existing and that row got changed, and once the row got changed, the percentile found will become true. Suppose pin number 39 was not at all there. So will the percentile found become true? No, it will become false. Similarly, percentile not found is logically opposite to the percentile found. There is the third one which is very important, which says whether we can still use the cursor or not. And that attribute is percentile is open. Percentile is open. As I said, whenever we try to process a SQL statement on a particular table, Oracle will create a context area, and based on the SQL statement, some rows with certain column values will be retrieved and stored in that area. That rows and column values are called as active set. If this active set is existing, then isOpen will be true. If this active set is not existing, then isOpen will return false. Okay, but do remember there are two types of cursors. One is implicit cursor, second is explicit cursor. Implicit cursors are already created by the Oracle itself for us, and explicit cursors are those which we create for our own selves, for our control. And implicit cursor, there is only one cursor which is created by the Oracle, whose name is SQL. The name itself is SQL cursor. Okay, so this SQL cursor, its isOpen value will always return false. This is again an important interview question. For implicit cursor, SQL cursor, isOpen, percentile isOpen attribute value will always return false, because as soon as the statement is performed, has got executed, that implicit cursor will be automatically closed. But when we create a cursor from our own side, unless we close it, it doesn't get closed. That's why it can still remain as open. Explicit cursor. Explicit cursor is the one which we create from our own side. Okay. Implicit cursor is created by the Oracle, and as soon as the processing of the SQL statement is done, it will close that cursor. So isOpen will always return false for the implicit cursors, but it may return true for explicit cursor if it is open. Percentile row count returns the number of rows that were affected. You applied a say update, set total is equal to marks1 plus marks2 plus marks3, and inside the table there were 3 rows. So all the 3 rows marks will be added individually, and total will be calculated for all the 3 rows, right? So percentile row count will return what? 3. Clear? Returns the number of rows affected by a insert, update or delete statement. So let us try to first discuss about implicit cursors. Implicit cursors are automatically created by Oracle whenever a SQL statement is executed. Okay. Now, if we create an explicit cursor for our program, will there be an implicit cursor still existing? No. When there is no explicit cursor for this statement, then only implicit cursor will get created. Once you create an explicit cursor for a SQL statement, implicit cursor will not be created. Can we use implicit cursor to control it? No, we cannot control the implicit cursor. Okay, we can just learn that it is there, but we cannot control it. For explicit cursors, using these attributes, we will control it. So whenever a DML statement such as this is issued, a cursor is associated with that particular statement, and this implicit cursor will get finished off, will get closed as soon as that statement gets executed. The name of that implicit cursor is SQL. The name of the implicit cursor is SQL. So just to show you that SQL exists as a cursor, I've kept this particular program. You can go through this particular program wherein I am checking SQL percentile not found. If no rows are available, then this particular not found will be true. Okay. If no rows are there, no customers selected. If some SQL found has been done, then I am checking how many rows got affected by it. I am writing total number of rows selected. These many number of customers got selected. Like that, you can make use of the row count, you can make use of the percentile found or percentile not found. Get to know what is this implicit cursor. But do remember the implicit cursor name is SQL. Now coming on for explicit cursor, let us quickly go for how do we create it. To create it, we require these below 4 steps. Whenever we try to work with explicit cursors, we require these 4 steps to be followed. First one is the declaration of cursor for initializing in the memory. First we need to declare the cursor. To declare the cursor, this statement is very simple. You have to write a cursor keyword, whatever name you have to give for the cursor is keyword. Then you have to write the select statement onto which you have to associate this cursor with. For example, I'm trying to create a cursor customer and C underscore customers with a statement like select ID, name, address from customers table. Now, once we have created this cursor, we have to open that cursor in order to use it. To open the cursor, we have to write a keyword open, and then we need to mention what cursor we want to open. Once it is open, we can fetch the data from it. To fetch the data, we have to write fetch C underscore customers, which is our cursor name, into so and so variables. Do remember, always you need to memorize how many columns you have mentioned while creating this particular cursor. Whenever you are trying to fetch the value from the cursor, these values in their sequence will be fetched up. So you need to write exact sequence corresponding variables here. Okay, in the select statement, what columns you have mentioned, in the same order you have to mention your variables into which the column values are to be read. This is a compulsion for your fetch command. Now once the data is fetched, first row data is fetched, automatically the cursor will point to the next row. How it is pointing to automatically to the next row, that is internal implementation of Oracle. We need not worry about it. All the rows working is over. Once our work has got finished, we can close the cursor by using close C underscore customer. So what are the first steps that we need to work around with whenever we are trying to work with explicit cursor? First one, declaring the cursor in the memory. Second, opening the cursor for trying to make use of it. Third one, trying to fetch the data from the cursor, row by row, first row, second row, third row, so on till the last row. Then closing the cursor. For creating the cursor, syntax is simple. Cursor, name of the cursor is the select statement. Example, I have kept it here. We are trying to make use of customers table and we are trying to retrieve the values of ID, name and address. To these three columns values, I am trying to associate a cursor called as C underscore customers. Once this cursor has been associated with it, it has to be opened so that it can be used. So to open it, we have to just write open C underscore customers. And once it is open, we can fetch the data by using fetch command, fetch C underscore customers into CID, CNAME, address. Okay. Now once your usage of data is over, you can close that particular cursor by using close cursor. So here I have kept a program wherein I have tried to create a cursor for this particular select statement which we have earlier referred. Now to use them, first we have to open them in the body. After opening, I don't know how many number of rows are there, so I am using a basic loop, and in that loop I am trying to fetch the customer's cursor into CID, CNAME, C address. But when to exit out from the loop? Exit when C underscore customers and its attribute not found becomes true. Whenever C underscore customers attribute not found becomes true, when there are no further rows are not found, when this particular condition becomes true, exit out of the loop. Okay. If it is not the condition, then Rdbms underscore output dot put underscore line display whatever has been read into the variables. And once all the loop has finished, close that customers. Okay. So now coming to the next topic, that is triggers, which is very brilliant topic. Trigger is the background running process. Just in basic terminology, it is a background running program, PLSQL program, which will always check for an event to occur, and whenever the event occurs, it gets executed. In simple terms, so again I'm repeating, trigger is a background running PLSQL program which will always look for an event to occur. Once the event occurs, it will get executed in the background. Okay. So Oracle Engine allows the user to define the procedures called as triggers that are executed by Oracle Engine itself whenever an insert, update or delete statement is issued against a table. So what are the events over here? Whenever there is an insert operation or an update operation or a delete operation, these operations will change the state of our table. Change of state of any object is called as an event. Okay, so whenever the insert event occurs or update event occurs, delete event occurs, this particular trigger procedure will get executed automatically by the Oracle. Okay, implicitly that's so triggers are stored programs which are automatically executed or also called as fired when some event occurs. Such in response to the following events. What are the events? Database manipulation, DML statements, or DDL statements, or some basic operations on the database such as set server output on, or set server error on, or whenever you log on, or whenever you log off, or whenever you start the database, or whenever you shut down the database. For these occurrences, you can write a trigger. Okay. So triggers could be defined on the table or view or schema or a database as a whole with which the event is associated. So what are the benefits of triggers? Sometimes what will happen is, let us imagine we will have a grocery store. In that grocery store, sometimes the price will be fluctuating. Today one price will be there, tomorrow another price will be there. So suppose you are making a table for containing the product price list, and if you update the price list of the products, fine, you have the current database. But if you want to get to know what was the previous price of that particular product prior to getting updated, will you still contain that particular price? No, it will be lost. So what you need to do is you need to create another table which will contain the previous price. And now before you update the current price, you have to first enter the previous price there. Then you have to come and update the current running price. So you have to maintain two tables now. As a human being, we are habituated to make errors. We may update the current database without even updating the previous historical database. So I want computer to do it for me. Whenever any entry happens in the current running price list, whatever was the previous price list should get automatically stored back in the historical table by the Oracle itself. So if you want to have some derived columns to be generated, then you will use triggers. Whenever you wanted to have, just give me 1 minute now. So what are the advantages of triggers? First one is to have some generated derived columns, just like what we discussed about the price historical record. Second is for enforcing referential integrity. Enforcing referential integrity in the sense, suppose if I say that the insertion operation is going to take place, and while inserting, let us say insert or update was being done onto students' marks record. Now, whenever the result was popped up for the student, if anyone tries to make any updation after the result was announced, should that updation should succeed? No, because results were already announced, so no manipulations are to be permitted, right? So if you want to have a referential integrity to be maintained, telling that once that particular results have been announced, no further manipulations are to be permitted, then you can have that referential integrity using triggers. If anyone tries to have that particular updation being done, they will be popped up with a message that you are trying to manipulate the database, which has been made as public. Even you can record that particular settings, who try to make an update in the database, at what date and time they made an attempt to update that particular database or manipulate that database by using event logging. Similarly, you can have the auditing whether a particular thing is working properly or not. You can check for the audit records, all those performances. Then you can even apply security and authorization, just like how we discussed about the marks updations here. And even prevent invalid transactions which may occur onto your database. So how many types of triggers are there? Triggers basically have been classified by various authors into various categories. Some of the categories I have listed here, but those are pertaining to what type of commands are going to be associated with the trigger. If the trigger is going to work on DML commands, it is called as DML triggers. If the triggers are going to work around with DDL commands, whenever any DDL command is issued, the trigger should be fired or executed, then that is called as DDL trigger. If any system updations have been done, for example, any user has logged in or logged out, or any changes have been done for the entire database, then that are called as system or database event triggers. And a special category of trigger called as instead of trigger will be used whenever you are trying to associate a trigger with that of a view. Okay, as you know that views are going to represent the data on behalf of a base table. Views are not the permanent tables. Views are temporary tables. The actual tables and the permanent tables are their base tables from which the view have been derived. So if you are trying to have a trigger associated with a view, it will, instead of the view, it will get associated with the base table from which that view was generated. Suppose if you are having a trigger which is composite of these things, then it is called as compound trigger. Then it is compound trigger. So these are the different categories of triggers that has been listed in some of the textbooks. In some of the textbooks, the triggers have been classified into before trigger, after trigger, and instead of trigger, or row trigger and statement trigger. Many different authors have given many different types for these triggers. Before trigger says that the trigger body will get executed before performing the SQL statement. Before making any changes to the database, first the trigger body will get evaluated. Then only based on that evaluation, it will let that particular statement, DML statement, to get executed. But if you want whatever is mentioned in the trigger body to get evaluated after making a change in the database, then it is called as after trigger. And if you want the trigger to get executed whenever a single row, whenever each and every row is being changed, then you are going to call that particular trigger as row trigger. So whenever a trigger row value is being changed, then a trigger will get fired up. But suppose not just one row, for all multiple rows, let us say update total. Update total is equal to marks 1 plus marks 2 plus marks 3. And there were around 50 rows in that particular student table. So my total will get impacted onto 50, right? It will get calculated for 50 different marks. So if you want a trigger not to be executed 50 times, only once for that particular statement update query, then you will have a statement trigger. So basically, how many types of triggers we have learned now? Can anyone list it out in the chat box? How many types of triggers we have learned now? 4. Any other member? Actually, there are 1, 2, 3, 4, 5, 6, 7, 8, and 9 type of triggers that we have discussed. How many? 9 different types of triggers we have discussed. But I prefer you to write for the types of triggers of this nature. 1, 2, 3, 4, 5. These 5 are good enough. Now, when will this DML query get the trigger associated with the DML get executed? Should the trigger get executed before DML query got executed, or should the trigger procedure get executed after DML query gets executed? It becomes before and after. Should the trigger get executed for each and every row that was getting changed, or should it get executed for the SQL statement that was executed once for that is SQL statement? So it becomes row and statement based. Basically, there are 5 different types of your triggers. 5 different types of your triggers. Okay? Hope you have understood it now. So the combination of triggers are also possible. Before statement, before row, after statement, after row. So this is again a big topic. So here I have kept a syntax for the trigger, how the triggers are made. To define a trigger, you have to use a keyword called as create or replace trigger. Then you have to name that particular trigger. And you have to mention which category of trigger you want to have. Before type or after type, or else if you are creating a trigger for the view, then instead of. Either of these you have to mention. And now you have to mention in the below line on what DML statement do you want the trigger to work on. Do you want it to work on insert or update or delete? Which SQL statement, DML statement you are going to associate the trigger with. Now, when this insert, update or delete are being checked, onto what columns the trigger should get associated with. Like I said, marks were getting updated, were manipulated, right? So I was associating the trigger with that of marks. On what table? Student table. Referencing old as O, whatever old values were there, we'll call them as O, and whatever new values are there, referencing new as N. This will help us to shorten that form. Okay, we'll instead of old we'll write O, and instead of new we'll write N. That's all this line says about. Do you want it for each row or for the statement itself? Then when should this trigger get executed? What is the condition on which this trigger should happen? So what is the body of the trigger? Here you should write the logic, what you want to do when such an event occurs. So this syntax, you should memorize it damn surely. Trigger is an important question. It may come into short or it may even come into long. Okay. So each and everything's definition and its explanation, I have kept it here. You can go through them. Now one example I have kept it here. I am writing create or replace trigger. Display salary change is the name of the trigger. Before delete or insert or update, I have associated this particular display salary changes onto 3 DML commands now. But when should this trigger get executed? Before performing delete or insert or update onto customers table. And it should check each and every row. Whenever any row changes, it will get executed. The trigger body will get executed. Okay. What is the condition? When new ID, new.id is greater than 0. New value which has got changed up, that new value is greater than 0. Whenever the new value is greater than 0, then only this particular trigger will get executed. So in the body of the trigger, what I'm trying to do is I'm trying to have a variable called as salary difference. I'm taking that variable, after declaring it, I'm trying to calculate what is the difference between the new salary and the old salary. Do remember how I'm trying to access the new? I'm using colon new. I'm using colon new. Similarly, colon old. These are the two attributes of your trigger which will contain the new value which will get changed and the old value which was there prior to the change that has occurred. So I'm trying to check what was the new salary that was inserted and what is the old salary that was already existing. What is the difference? I am putting both the salaries back again on the screen and finally I'm trying to say what is the difference between them to the user. Okay, so whenever any change happens to the salary, let us say for example update customers set salary is equal to salary plus 500 where id is equal to 2. Whenever this particular row gets changed represented by id is equal to 2, that particular row's salary will get displayed. What is the old salary? After adding 500 it became 2000. Then what is the difference? It has also shown. I have written a simple logic here, but you can write any complicated logic in order to stop that change also. For example, if the new difference is less than 3000, then it should pop up a message telling the user that this operation cannot perform and you can roll back. You can apply a rollback command and that operation will fail. So like that you can define your own triggers which will be very helpful for the users. Here I have kept another example for you which we were trying to discuss about in the initial discussion, wherein there is a product table which contains these many columns. There is another product's price history table which contains similar type of records. So whatever changes happen in the product, it should get first stored in the product price history, then it should change in the product. So to demonstrate that, I have created a trigger here, trigger example program. Please go through it and try to understand how we are trying to make use of that particular trigger. Okay, there is one more trigger example I have kept for your practice based on before update or before update statement level, row level. What is the difference that comes up here? Please try to understand it by following the instructions given there. Now how to test those 4 programs? I have shown that particular message also here and their outputs are also displayed. For the almost last topic, packages. PLSQL packages are basically nothing but the schema objects that groups logically related PLSQL types, data types, variables, as well as subprograms. Those subprograms may be functions or procedures. So what is a package composed of? PLSQL types, variables, and subprograms. Those subprograms may be functions, may be procedures, or may be triggers or anonymous block of code. Okay, so whenever you want to create a package, there are 2 parts of the package. One is package specification, second is package body. Package specification will contain the declaration of all the types, variables, and subprograms. It will only contain the declaration of those things. Whereas package body will contain the definition of those types, variables, and subprograms. So in case of specification, you will not write any logical statements inside it. Logical statements will be written in the package body. Package specification will contain only the declaration part. Since it is containing only declaration part, it gives us what is the names of various functions that are available in the package, what are the various variables that are available in the package, what are the various data types that are available in the package. So since it is to be known to common user, its nature is public, its visibility is public, whereas its internal implementation is hidden, it's private. So package is a collection of PLSQL elements that are packed or grouped together within a special begin and end syntax. They are a kind of metadata blocks. They are a kind of metadata blocks. So what do we keep in case of our cursors? We can keep, what do we keep in our packages? We can keep the variables, we can keep the types, we can keep the procedures and functions. On top of that, we can keep the constants as well as cursors. And if we have got any exceptions, user-defined exceptions, we can even keep them. Here on the right hand side, I have kept few of the advantages of packages. Coming on for package specification. Package specification provides just the declarations of types, variables, constraints, exceptions, cursors, and subprograms, which can be referenced from outside of the package. So package specification is not going to contain any detailed body implementation of those declarations. Okay. All objects in these specifications are called public objects. They are publicly accessible. But the subprograms implementation, the values that are to be there inside the variables, the definition that it became a constant, the definition for the exception handling mechanism, the definition of the cursor will all be kept inside package body, which is private. Okay. So package, here I am trying to create a specification here. So to create a package specification, what you need to do is you have to write a keyword create package. Package specification is not the keyword. For creating a package specification, you have to write the keyword package. Okay. Create package. The package name that we wanted to give, customer underscore salary, as what procedures you have got in that particular package to be grouped up. Here I have listed only one procedure, which we earlier created finding of salary. If you have got 10-15 procedures which are related to the customers, then you can group them here by just listing their function names as well as their categories, whether they are procedures or functions and what are their parameters list. Once you have listed them, you can close your package specification by using end keyword in the package specification name. Once you execute this, you will get a response that package got created. But do remember, you have just specified the declaration of the procedures. In the package body, you have to define them. So in the package body, you have to mention the various codes for various methods declared in the package specification. And to have the package body defined, you have to follow the following pattern, syntax. Create or replace package body. Package body is the keyword. Package separate, body separate. These two are two separate keywords. Name of the package which you declared earlier. What was the name of the package that we declared earlier? Customer underscore salary. So you need to declare the same name over here as what procedures you declared here, no? All those procedures should be defined here. So I am having that procedure find underscore salary, and I am trying to give that particular procedure parameter is what is its definition I have written here, and I am closing my procedures body, and I am closing this procedure. Package got created and package specification got created, package body got created. How do we use those packages? In order to use those packages, you have to mention the package name and what element you want to use from that particular package. Element in the sense, it may be a procedure, it may be a function, it may be the variable which was composed in the package, something like that. For example, in case of ours, it's find sal. The element name is find sal. So it is present inside what package? Customer underscore sal. So in order to use it, I am using customer underscore sal dot find sal. I am passing the code for calculating that salary as whatever has been entered, whatever customer ID has been entered from the keyboard. Okay. Here I have listed few of the built-in packages that has been given by the Oracle for us. One of the package was Rdbms underscore output, which we have used a lot. Rdbms underscore output. Put underscore line was our PLSQL equivalent to printf function. Like that, we have got UTL file, we have got Rdbms underscore alert, we have got Rdbms underscore alert, mail, HTTP, DTL, SQL. You need to remember any 5 of them. This is again an important question. Just remember the names of the built-in packages, if possible, along with their descriptions, why they are used. I hope with this we will finish the 5th unit also. So, till here, is there any doubt for anyone in the 5th unit? We are left with only 2 minutes or 3 minutes, I think so. We discussed about these 6 topics in the 5th unit. Is there any doubt for anyone? With this, we have successfully completed the 5th unit of our Rdbms. Is there any doubt in the 5th unit? Okay, fine, then I am closing this session. If you have any doubts, you can refer back to the videos that we have recorded back. Okay.